Hello ladies and gentlemen, I am Dr. Claudia Albers, Planet X research and professional physicist, and today I'd like to bring to you another one of my articles. This one is entitled, Is Planet X Here, or Are Chemtrails Responsible for Pink Clouds? Now in article 108, entitled Planet X in the Sky, the Evidence Anyone Can See, I wrote about the fact that we have pink and other strange colored clouds in the sky, and that this is evidence of light sources or Planet X objects being in the sky, which emit these strange colors. However, some people are casting doubt on this by suggesting that these strange colors can be caused by chemtrails. So this article is in response to that. Now, the multicolored light sources which give rise to strange colored clouds have to, of course, be stars, as only stars are able to emit light. And these stars are actually rejuvenated old stars, which I have called Planet X objects or stellar cores. I've been writing about these objects for many months now. And these are stars that have gone through the red giant and white dwarf phases as part of their aging process, and so have lost most of their layers of ionizing material to the point that the star's core has become exposed. And you can find more details about this aging process in my article 98 entitled Planet X and Stellar Evolution, and details about the two types of stellar cores we find in the inner solar system, in the sun's corona, and their rejuvenation process, which is the regaining of their ability to emit light. And they do that by, of course, draining energy and plasma from the sun. So more details on that you can find in article 100, Planet X, the rejuvenation process. Now, this is what I used in article 108. I'm going to use the same here, which is Newton's color theory of light. I'm going to do a little summary first for those people who haven't watched that yet. But Newton's color theory of light is about 300 years ago. 300 years old, because he published his experiments in 1672, I believe. So it's over 300 years old, but it is still easily verifiable because what he did was use experimentation and observation as physics should be done. Very few physicists that are publishing in this area are actually doing what Newton did at the time. But this is still easily verifiable by anyone, and it leads to the conclusion that pink clouds have to mean that there has to be a source of light in the atmosphere that emits that color. So pink clouds means there must be a star in the sky that's emitting pink light. But Newton's theory of light can be verified because we can take, say, 3 flashlights which emit white light and place 3 filters on them, 3 different filters, 1 red, 1 green, and 1 blue on each one, so that each flashlight emits a beam in the 3 primary colors of light. So, because that's what Newton did. He divided up a visible light or white light into 3 main frequencies, red, green, and blue. And if we then combine these 3, that is, if we intersect the 3 beams on a screen, you will see that white light is the result. So that verifies Newton's theory. And the other thing we can do is also realize what happens when we combine green and blue. We get this color, which is cyan, a mixture of the two, and that's a secondary color. And when we combine green and red, we get yellow. That's the other secondary color. And the third secondary color comes from combining blue and red, and that's magenta. And that's what we see a lot in the sky, is this magenta color. Another word for magenta is, of course, pink. If we combine all 3, the green, the blue, and the red, the 3 primary colors, we get white light back again, which shows that white light is made up of these 3 colors. Now the sun emits white light and the human eye detects white light, so the human eye detects these colors, but the sun will look pale yellow inside the Earth's atmosphere because the atmosphere scatters blue light out of normal white sunlight. So the sun ends up looking pale yellow and the atmosphere looks blue because blue seems to be coming from every position we look at inside the Earth's atmosphere. And that's because the molecules in the atmosphere, mainly nitrogen, absorb blue light and re-emit it in different directions. That's called scattering. So clouds, and this is what we're going to focus on, also scatter light, but they scatter all wavelengths. That is, they scatter blue, green, and red. Whatever they are illuminated with, they will scatter. That is, they absorb and re-emit in different directions. So when we look at a cloud, we see all these different wavelengths coming from each cloud. And we know that all of these three, of course, will make the cloud look white. This is why clouds look white. They can, however, look gray when the water droplets, and clouds are made out of water droplets. When these water droplets increase in size, then light cannot penetrate them as well. So some of the light is lost, so they start to look a bit gray. And then clouds can look a little reddish, but only when they are close to the setting sun, which must be even redder than the cloud. And the reason for that is if an observer is looking at a cloud and a cloud is in front of the sun or close to the sun, the setting sun's position, then this red light is going through this cloud before reaching the observer. So the cloud is being illuminated by this red light, but there will still be some light that's coming from the sky that's illuminating the cloud. So the cloud will not look as red as the sun. If it looks redder than the sun, then there's a problem. We'll talk about that again just now. So as we can see here, this illustrates what I've just seen, that if the sun comes in its sunset position, and what happens is the blue is scattered out, and then the green starts being scattered out, so that what's left to continue in a straight line, and therefore to an observer who is looking at the sun will look red. And then a cloud being illuminated by that light between the sun in its sunset position, the observer would look reddish, not as red as the sun. But a cloud above the observer, so higher up in the sky in terms of the observer, will still be illuminated by light that does not go through as much of the atmosphere, that all the green is scattered out. So it will still look yellow, and there will still be blue coming in from other parts of the sky. So this cloud would still look yellow. At least it should look yellow. I mean, it should actually look white. It may look a little pale yellow, but it's mainly white because enough blue comes in for it to, we get a good mixture of all the three primary colors, so that the cloud looks white to us. So this again illustrates what happened. The sun emits white light, so it looks white outside the atmosphere. So in space it looks like that. Inside the atmosphere it will look yellow because the blue light is scattered, and then the red and the green gives us yellow. But at sunset the green starts being scattered out as well, so only the red continues in a straight line. So that means the sun will look red, and a cloud close to the sun's sunset position will look red. But a cloud above the observer, so it would be higher, would seem to be higher up, or the observer would have to tilt the head back to look at it. It would still be white because it's still being illuminated by a pale yellow sun. Now we are seeing magenta colored clouds all over the world, and according to what is supposed to be happening, according to our understanding of clouds and how light works, this is impossible. And this is what leads to the conclusion that there are extra light sources that are emitting these colors in the sky. So let's look at this. If we have a cloud, and this is a cloud made out of water, this cloud is being illuminated by yellow light from the sun, which is made out of red and green. And it's being illuminated by blue light from the sky. So it's being illuminated by all the wavelengths, and it scatters all the wavelengths it's being illuminated with. Then it should look white to us, but it doesn't. If the cloud looks pink, that means, and pink is made up of blue and red, that the green has disappeared. Now, so how is that possible? Now, first of all, it's important to realize that the sun is still emitting this green light. The sun is weakening and it's growing in size as stellar cores acquire stable positions in the new multiple star object, which is forming at the center of the solar system. And you can get more details about that in Article 77. The sun is growing in size. But the sun has to still be emitting green light, and this light is still getting down to the Earth's surface because green leaves on trees still look green. And if there was no green light, the leaves would not be reflecting it, and this light would not be reaching our eyes. So if no green light was getting to the Earth's surface, all green plants would look black to us. So this is what happens. A green leaf is made out of a material which absorbs the other wavelengths, the red and the blue, and it reflects the green. So the green gets to the observer's eye, so the observer sees this leaf as green. And as long as we see green leaves as green, there has to be green light hitting those leaves. If there was no green light here, if that was gone, there would be no green light reflected. And when no light comes from an object, we see it as black. So we would see the green leaf as black. Now, chemtrail clouds, this is very important, like normal clouds, are also made out of water. The water droplets in normal clouds usually contain small particles of dust. And these small particles of dust or whatever are called cloud condensation nuclei, because water vapor condenses into liquid droplets onto the solid surface of these particles. The difference between chemtrail clouds and normal clouds is the type of CCNs, or cloud condensation nuclei, that led to the condensation of water vapor into liquid droplets of water. So in the case of chemtrails, these particles are mainly heavy metals like aluminum and barium. But clouds are still almost 100% water, except for these tiny little particles. And so they still scatter light, whatever light illuminates the cloud, in the same way. So chemtrail clouds scatter light in the same way as naturally formed clouds, because the scattering of light is to do with the water droplets. And chemtrail clouds are still made out of water droplets. And the type of CCNs that led to the formation of that water droplet does not make any difference to the scattering of this light. So in other words, optically, chemtrail clouds act the same way as normal clouds. They are optically identical. And this shows how these droplets form, which leads to the formation of clouds. We start with water vapor in the air, then there's a CCN, which may be a naturally occurring one, like a dust particle or salt crystals, or it can be an artificial one, the one that come from chemtrails, such as aluminum or barium particles. These are artificial. But this still leads to the condensation of water on the surface of that cloud condensation nuclei. And so that's how a water droplet forms. There's the water droplet, and clouds are made out of these water droplets. Now, in addition, anyone who observes the sky can see that clouds actually change color from white to magenta or pink as the sun sets and the star illuminating the part of the sky that is under observation of that particular cloud changes. We usually can actually see a white cloud start to change from white to pink, and we can see that this happens in stages as the illumination which is illuminating this cloud changes. So this usually happens at sunset. We can look at the clouds and they look white first, and then they start to turn pink. Sometimes they turn very pink, and sometimes they start turning white again before the sun sets. So this means that these are clouds that scatter whatever light they're being illuminated with. If they're being illuminated with white light, they will scatter white light. If they're being illuminated with pink light, they will scatter pink light. And if the color of the clouds was to do with the material it was made of, then this would not happen, because a material that is usually reflects pink light, just like a green leaf is green because it always reflects green light. It would always be pink. It wouldn't change from white to pink. So let's suppose we have a magenta colored plastic leaf. It would be illuminated by all the colors, and it would absorb green, and it would reflect the red and the blue, and which is magenta. So this is why it would look magenta to the observer, and it would always do this no matter what light it was illuminated with. As long as the colors that it reflects are in the light, it would look the same color, because it's to do with the material it's made out of. And this is not what's happening with clouds, be they normal clouds or chemtrail clouds. They actually change, which shows you that what they are doing is scattering whatever light they're being illuminated with. They're not reflecting light due to the material they're made out of. Thus, the color we observe in the clouds has to do with the light illuminating them. The only logical explanation for the magenta and other colors seen in the sky is that these clouds are being illuminated by other stars, which emit these colors, as illustrated here. So this is a white piece of paper, and a white piece of paper scatters light just like a cloud does. So if it's illuminated by pale yellow light, it will look pale yellow. We have an observer here, so the observer is seeing whatever light is illuminating this paper on the other side of the paper, and there's a flashlight emitting pale yellow light, just like the sun emits pale yellow light. So to the observer, this paper would look pale yellow as long as it's only pale yellow light that's illuminating it. But if in addition to the pale yellow light we have another light source that emits magenta or pink light, then the observer would see the paper as pink. This is what it will look like. It will look a little paler than perhaps this pink because it's a mixture between the pale yellow and the pink, but definitely will look pink because it's being illuminated by the pink light source. So in the same way, these chemtrail clouds, which of course, as I mentioned before, are made out of water droplets just like normal clouds, they can only look pink for one reason only. They are being illuminated by an extra light source which emits this color of light. This cannot be due to the sun. The sun cannot emit this color. The chemtrails are not different enough from normal clouds to be able to either absorb the green light, because there's green light coming from the sun, and they cannot absorb green light. They simply scatter, that is, they absorb and re-emit whatever light frequencies they're being illuminated with. The sun is still emitting green light, so they have to scatter green light as well as red and blue. The fact that they look pink tells us that there must be an extra light source in the sky illuminating this cloud with that color of light. Now, in addition, the appearance of red clouds whilst the sun still looks yellow is impossible and is an indication that the atmosphere is being illuminated by an extra red light source. Also, clouds higher up in the sky, with respect to the observer, will be illuminated with yellow light coming directly from the sun and blue light coming from the sky, and will therefore still appear to be white. If they are also red or some other color, this too is an indication that the Earth's atmosphere is being illuminated by a star which is emitting that color of light. And this particular photograph I would like to talk about again. I put it in article 108 as well, but this is so interesting because, as you can see, there are white clouds down here close to the horizon. And as long as there are white clouds, there has to be a source of light which is emitting white light, or all the frequencies. So this would likely be due to the sun, which is still white. It could be another star, but there has to be a star in the sky that's emitting white light. This is why we have white clouds, and specifically because they are close to the horizon. And if the sun is setting, the clouds that are closer to the horizon will be the ones to be closest to the color that the sun would look like to an observer. So if the sun is red close to sunset, we can expect the clouds close to the horizon to look reddish, but the clouds closest to the horizon here are white, not red. Clouds further away from the horizon are red. So this would mean that the sun is still maybe pale yellow. That's why we have white clouds. But then we have red clouds, and red clouds mean that there has to be an extra light source other than the sun, because the sun is still pale yellow. That's illuminating these clouds with red light. We also have this orange tone, and this has to be with a light source that's emitting this color, this orange. And then there is magenta or pink here, and this means there is another light source that is emitting this color, the magenta. So that means we would have 4 light sources. So 3 stars in addition to the real sun are illuminating these clouds. This is the only explanation for what we are seeing here. Now, these the stellar cores, these extra light sources, have been observed in the solar system. I've been writing about it for a while. I specifically like to use this photograph because it is so clear. It shows you exactly what these objects are. And why I call them stellar cores, because they are the solid core of what was once a main sequence star, but has aged, has lost most of its layers of ionization material. There's very little left. These seem to be one of the older ones. If you look at my article 100, I give details about the 2 types. They are the younger ones closer to the white dwarf's phase, and the older ones that are that have lost even more material and don't have the toroidal shaped envelope, and they shed whatever ionizing envelope or this material that's left on us. They shed it, they exchange it with the sun. Most of the material then is absorbed by the sun. They absorb plasma from the sun, and as you can see, this object is actually gathering a plasma that is emitting magenta light. So it's not surprising that we have these objects that are emitting magenta light and are illuminating our atmosphere. Now, in conclusion, chemtrail clouds may have different CCN, cloud nucleation nuclei, from naturally produced clouds, but they are still made out of water droplets and therefore optically identical to naturally formed clouds, and thus provide evidence for the presence of extra light sources in the inner solar system which emit magenta or pink light. These light sources are old stars or stellar cores like the one we see here. And this one was photographed in the sun's corona through a telescope, and it is accumulating magenta light emitting plasma. And it's thus not surprising that these objects are illuminating the Earth's atmosphere with this color of light. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.